In this third video, we're going to look at locating local maxima and local minima, as well as absolute maximum and absolute minimum. So functions can have hills and valleys where they reach a maximum or a minimum value. And a local maxima, and maxima is the plural of maximum, a local maxima is a height of the function f of x at x that is greater than or equal to the height anywhere else in that interval. So if we look at the function on the right, we can see that there are actually 2 points where there is a hill, and that is our maximum. So this one has 2 local maximum. A local minimum is where the height of f of x at x is less than or equal to the height anywhere else on that interval. So if we look at this next interval, we can see that this point right here in the valley between the 2 hills, that is a local minimum. So let's look at some examples. For what values of x, if any, does f of x have a local maximum? So we want to look for one of the highest points. And we can see, looking at this graph, that we have a hill right here. So there is a local maximum when x equals 1, and the value would be f of 1 equals 2. Let's see, at what value are there any minimums? So where are my valleys? I have a valley here, and I have a valley here. So I actually have 2 local minimum values. So the first is at when x equals -1, and the second is when x equals 3. And the values would be f of -1 equals 1 and f of 3 equals 0. So now we want to find intervals where f is increasing. So where is f getting bigger? So if we look, we can see it's getting bigger from -1 to 1, and we can also see it's getting bigger from 3 to infinity. So there would be 2 areas of it where f is increasing, and we would write it in interval notation, where the interval of -1 to 1, and it's bracket because it includes both, and the other interval would be from 3 to infinity because it's got an arrow. That means it goes on forever. And whenever you use the infinity symbol, remember, you use a parenthesis beside it. So find the intervals where f is decreasing. So it is decreasing in 2 spots. So it's decreasing from -infinity up to and including -1, and then it's also decreasing from 1 to 3. Both are included in our brackets. So when we want to locate an absolute maximum or absolute minimum, sometimes it's called global, meaning it is the highest maximum or it's the lowest minimum. Okay, we want to look at a couple of things. So first off, there can only be one absolute maximum and one absolute minimum. There can be more than one local maximum and minimum. So looking at this graph, we can see that there are 2 maximum points. So the lower maximum is considered a local one because it is not the highest maximum amount. The second location would be considered our global maximum, or as we tend to call it, it would be our absolute maximum. Okay, and in this case, there is only one low area, and that would be our local minimum, because our line continues on in either direction, and it goes down going to the left and it goes down going to the right. There is no absolute minimum in this function. pictured here. So let's look at a couple examples. So for each graph of a function y equals f of x, find the absolute maximum, the absolute minimum if they exist, find any local maxima or local minima. So first off, we're going to identify the domain. And as you can see, this is a piece of a function. It starts at 0 and it goes all the way to 5. So our domain would actually be 0, 5. In this case, there is one absolute maximum because we know there can only be one, and it is located at f of 3 equals 6. The absolute minimum would be at the bottom here. So it is located at f of 0 equals 1. That is the lowest point in our function. The local max amount on here, if we look at that, we can see that there is a local max at of 6 at f. So this is also a local maximum. So there's a local maximum of 6 at x equals 3. And that's the same thing as what we wrote before, where we had f of 3 equals 6. Okay? And we can see there is a local minimum at 4 when x equals 4. And same thing, we could also write this as f of 4 equals 4. So let's look at this next example. Our domain starts at 1 and goes around to 5. However, we have an empty circle right in the middle of our line, so that means 3 is not included in our domain. So we would write it as x, the set of x, where 1 is less than or equal to x, less than or equal to 5, and x cannot equal 3. So in this case, we have an absolute maximum at f of 5 equals 3. However, if we look at the bottom here, that's an open circle. That's our lowest point, but it's an open circle, so that means it's not included. So therefore, that we have no absolute minimum because there is no smallest value. And when we look at this, there's no hill on either side, and the valley going down, the bottom point is empty, so that tells us that there is going to be no local max or minimum. Okay, let's look at two more examples. So the domain for this one is going to travel from 0 all the way over to 5, and both ends are included. So the interval would be done with brackets. The maximum amount here, this is the highest point on our function. So our maximum is going to be f of 5 equals 4. In this case, when we look at our minimum amount, we have a constant. It goes straight across. So that means we're going to have multiple absolute minimums. And we would say any number in the interval from 1 to 2 would be our absolute minimum. Because there is no hill, we have no local max. Our local min is going to be the same thing as our absolute min. So our local min is going to be at 1 for every x in the interval 1 to 2, because we know our y value on that interval is 1. Last example, and when we look at this one, it starts at 1, 4, which is open, so it's not included. We go down to 2, 2, which is an open circle, which means that point is also not included. And then it seems to go forever as it gets closer to 5, but does not touch 5. Because remember, the dotted line indicates an asymptote that is never being touched. So our interval on this one when we list it is going to be x from 1 is less than x because the circle means it's not included, which is less than 5, and we know it never touches because of this asymptote. So we also need to put in there that x cannot equal 2. Now, for the absolute max, our highest point is 1, 4, which is an open circle. And we know that means it's not included, so there is no absolute max value. Our absolute min, it goes forever down towards 5. So there is no absolute minimum. So our local max, we do have a hill with a closed circle located at 4, 3. So we do have a local max that has a value of 3 at x equals 4. Now, the valley is an open circle. So once again, if it's an open circle, that means there is no local minimum because that is not included.